It is starting to get to the point in the day where my room is getting very hot, so I've turned on one fan. We'll see how the rest of the day goes. Once I'm done speaking my way through this class, I'm going to go and make myself some rice and maybe write up the 9th class so that I'll record 2 this afternoon, and then I'll have 4 classes to upload when I go to UMA this evening. But that being said, the next thing that we need to talk about is ArrayList. ArrayList is a special class that is built into Java that makes working with arrays a little bit easier in some aspects and a little bit more complicated in others. And to top it all off, ArrayList in Java is actually quite a bit more CPU and memory intensive than your average array, just because of some of the things that it is capable of doing. But that being said, ArrayLists are extremely powerful. One thing that is extremely helpful about ArrayLists that I talked about earlier is that ArrayLists dynamically size themselves. You don't necessarily have to tell them a size to start with. If they aren't big enough, they'll just make themselves bigger. And you can't just use ArrayList right out of the box either. It's not like a regular array in Java. You do have an import statement that you have to use, which I'll put in my program now, java.util.ArrayList. It's stored in the same location as scanner. It's just the last word is different, obviously. And now let's look at an example of how an ArrayList might be created, because there is definitely some funniness that we'll have to explain. So let me type this out real quick here. And you're probably already noticing, that I'm running out of space on my screen here. There we go. It's better. You're probably already noticing that there are some things that are different. So let's talk about this a little bit. The first thing is ArrayList integer. Now, obviously, this should be something that you're familiar with already. This is the type of variable that we're creating. But there's this extra bit on the end of the type here. This is what is known as a template in Java. Templating is way beyond the scope of this class in its entirety. We won't talk about templating at all beyond what we talk about here, because it's a fairly advanced topic, and it can be hard to really get it across accurately to new programmers that haven't had a whole lot of experience with objects and using them. So basically what we're doing here is defining a subtype. Specifically, we are defining what the ArrayList can store for a value. Now, why am I using the word integer? Well, let's go over that for a minute. The reason why I use integer is because while ArrayLists are extremely powerful, one of their caveats is that they cannot natively store primitive types. That is, int, double, boolean, etc. So Java had to work in a way to circumvent that, so you could still store numbers in ArrayLists without having a whole bunch of problems. So they created something called wrapper classes. Wrapper classes are literally classes that are designed to encapsulate a primitive type in an object, sort of holding it there so it can be used with things that require objects in order for them to be able to work. And ArrayList is one of those classes that requires an object in order to be able to work. So that being said, integer is one of those wrapper classes. And there is one for double. Double looks like this. And there's also one for boolean. Boolean looks like this. And basically, with most of the primitive types, with the exception of int, I believe, int and char, actually, it's mostly just the capital case version of whatever it was that you wanted to have for a primitive type. So double is just with a capital D, Boolean is just with a capital B. I believe short is just with a capital S. And primarily speaking, the only one that you'll have to be concerned with is int is not capital int, it is capitalized integer. So keep that in mind. But wrapper classes provide the same functionality as a primitive type plus the abilities of an object. More often than not, your wrapper classes will actually have extra methods in order for you to be able to complete certain tasks. But for the most part, just know that right now the wrapper class is being used so that we can put a primitive type inside this array list. So the next thing, obviously, is our name. That goes without saying. And our equal sign. We need to set this equal to something so we can use it. We talked about new a little bit earlier. We are creating a new ArrayList object, a new instance of an array list that we can make use of later. We have to do it this way, otherwise our variable won't work correctly. We'll get errors when we try to run our program. And then, of course, we name we call the constructor, we call the named function, the named method that creates our new object. And in this case, it follows the same format as what we've seen with scanner, with the exception of we add in that template portion. We add in that integer piece. So we name our type, we then name our subtype for this array list, and then we have our parentheses to define that this is actually a method. This is actually a constructor, which is a special type of method. Now, you could put a number in here that defines an initial size of your array list. And this is helpful when you are working in Java with much more heavy memory constraints, or if you're working with bigger data types. Integer by comparison is fairly small, but if you're working with bigger data types that can be many bytes, many kilobytes, many megabytes in size, it is often better to actually define an initial size rather than ArrayList try to dynamically size for you and resize itself as you go, simply because there's a lot of overhead in having to rework the size of an array list that happens in the background in Java that you don't have to worry about, but can definitely slow your program down if you either have a very small amount of memory that you work with, have a very slow processor that you're working with, or if you happen to be running out of memory, you could run into problems there as well. And Java will throw an error if it does, in fact, run out of memory while it's trying to run your program. More often than not, you don't have to worry about this on a regular computer. It is a concern with the RoboRio, our robot controller, but it is much less of a concern than it was when we were using the previous generation of robot hardware, which was known as the C-Rio. And we'll talk about that when we get to the robotic specific portion in the next class. When we talk about that. But for the most part, you'll never really have a reason to define an initial size. And more often than not, when you're doing stuff, having an initial size doesn't really make much sense because you're going to be adding over and over and over again, and you may not necessarily know what the best initial size will be. And taking a random guess may require that you allocate more memory than you really need for an array list, and that will create problems for yourself as well. But that being said, let's try adding some values to this array list so we can talk a little bit about the methods that are used when we work with some array lists. I'm actually going to pause the video for just a minute. Okay, had to check something. So adding to an array list is quite a bit different than what you would do in order to add to a regular array. Because an array list is an object, which means it has methods that you have to use in order to be able to interact with it. So for this, let's use the same values that we used previously. So we're going to call some array list, and we're going to call a method called add. Add will add one value to your array. So in this case, I'm going to do something a little bit funny that we haven't seen before. I'm going to do sort of the creation of an object inside of a method call. Essentially what I'm doing here is I am creating a new integer and then immediately storing it in the array list. I'm not saving it anywhere else. Once it's in the array list, it's there, it's good, I don't have to worry about it anymore. And this is perfectly legal. My program will compile fine and it will run fine. One thing that I would like to show you is that this also works. Now you may be wondering, well, wait a minute, we're using an object, not a primitive type. How does this work? Java is smart. With the wrapper classes, like integer, double, boolean, you can do stuff like this. It will allow you to do stuff like this. However, I don't necessarily recommend it. In fact, I would prefer that you do this. I like to see it this way simply because it speaks to me and says that you understand that what is being stored there is not actually a primitive type, it is an object. Because if you just type 48 without doing the new integer portion, Java is actually creating an object out of that. It is not storing it as a primitive type. It is being stored as an object, and Java is just doing the grunt work in the background for you. With this, you know that it's an object. You know that when you work with it, it is in fact an object, and that is what is going on. So let me add my last value here. Now this is same set of numbers as before, except this time we're doing it in an array list, and we've seen add. Now add is one of 4 methods that we're going to be going over today very quickly as we talk about ArrayList, because ArrayList will actually be used for your assignment. So if you have any questions about ArrayList, please make sure you let me know, because there is a lot to it, but it is very similar to what we just talked about with arrays. It's just in the object, the proper object format. It is, in of itself, it is its own object that was created specifically for this purpose. So what we're going to do is we're going to create our for loop again. And in this case, we're going to do something a little bit different when we create our condition. You'll see that as I finish typing here in a minute. Array lists don't have that length variable. You actually have to access the length of an array list using a method called size. And size will return 3, same as with length, except this is what you have to use. An array list is not an array. If you try to call length on an array list, it will not work. You must use size. That will be what returns the length of your array. And in this case, it will return 3. So now you may be wondering, how do we get values out of our array list? Well, there are 2 ways to do that, and it depends on your intentions, what you are actually trying to do with that particular value. So in this case, if we say system.out.println, and then we say some array list.get I, what this will do is it will go into the array list, and it will retrieve whatever value is at that index. It won't remove it, but it will grab it. Same as with our original arrays. It will simply pick up that value and put it in the print line, and the print line will print it. And we can actually see that in action right now. I'm in the wrong window. Let me run this again. Go. Okay. So negative 26, 48, and 9. As we should see. But there is another method that can be used that behaves slightly differently. So what I'm going to do is I'm going to say integer the first int is equal to some ArrayList dot remove 0. Okay, and then what I'm going to do is I'm going to copy this and go at it again. And what I'm going to do is I'm going to put a space between what we print the first time and what we print the second time. Okay, so I'm going to compile this, and we're going to see what it results in. So you see now our 26 was removed. Okay, now this space is artificial. I created this space on the line. So that means that when you call remove, you can actually pick up and remove a piece from your array, and your array will shrink. So 48 is now in the 0 index, same as with what a regular array would be, and 9 is now in the 1 index, and we have a size of 2. Okay, so let's see about printing sizes here. So let's say current size is some ArrayList dot size, and then we'll go system.out.println new size plus some ArrayList dot size. Okay, and then what we'll do is we will print the value that after we print the last size, what we'll do is we'll print the value that we removed, because remove does return the value that you removed. So what we'll do is we'll say value removed, and what we have to do is we have to say the first int dot toString in order to be able to access what the value is in the first int. Because remember that when you combine strings, if you start with a string, it has to be either a string or a number afterwards. If you use a plus and you don't say toString, it will think you're trying to add together a string and some random object type, and Java doesn't allow that. So what we'll do is we'll see what this results in. So let's compile, and then we will go like this and like this and like this, and you see that we print the first set, we say current size equals 3, we then have 48 and 9, the new size was 2, and the value that we removed was 26. So remove is there if you want to pick pieces out of your array list. More often than not, you'll be using add, get, and size, but remove is useful if you are collecting data points and you find that one data point is extraneous, it's an outlier, and you need to pull it out of the array list so that it doesn't affect an average, whether it be linear, logarithmic, exponential, what have you. That being said, this basically covers everything about arrays that I wanted to talk about. We're going to talk about the assignment next, which shouldn't be too bad. It's similar to what you guys have done before. It's sort of a combination between one of the calculator assignments and the password assignment in terms of repetitiveness. So that being said, I'm going to stop this video. We'll talk about the assignment, and then we will, at least I personally will, take a break and then move on to talking about the next class content.